Hi, YouTube people. Welcome to me talking about the killer constraint. So first of all, I want to talk about what the rules are of the killer constraint, because the killer constraint is actually probably the most complicated vanilla constraint in terms of its rules, because it's really two completely unrelated rules sort of mooshed together. And so those two rules are one arithmetic piece and one geometric piece. And most killer puzzles take advantage of both, although we'll see some killer puzzles that only do one or only do the other. So killer cages look like this. They have these sort of dashed lines and usually a number at the top left. And so the arithmetic part of a killer cage is that the sum of the digits that you place inside the killer cage has to equal the sum or the digit at the top left. So these four digits have to sum to 10, these four would have to sum to 11, these four would have to sum to 12. But there's also a geometric constraint, which is that you can't repeat digits within a killer cage. Now, in a normal Sudoku puzzle, I couldn't repeat digits within this cage anyway. But for this cage over here, I normally could make that digit the same as that digit and that digit the same as that digit. But if this is a killer cage, I would not be allowed to do any of those. None of those would be allowed to repeat. And so that's the geometric part. Now, at least when I first learned about killer cages, this seemed incredibly weird to me. Why is this the rule? And so I think there's two answers to that question. And so the first is, why did someone make this the rule in the first place? And the second is, why has this become one of the most popular constraints? And so the answer to the first question, why was this the rule in the first place? I think is because people were used to Kokuru. And so Kokuru, if you're not familiar with it, is a Sudoku-like puzzle where you get totals for the sum of digits in rows and columns and blocks. And then you have to match those totals with the sum of the digits, and you can't repeat digits. So I think the reason why when people went to go make killer Sudoku, they originally said you can't repeat digits is so that people's familiarity with the combinations from Kokuru would carry over. But I don't think that's actually the reason why it stuck. I think the reason why it stuck is that the geometric part of killer ends up being as important as the arithmetic part in a lot of the solves. And so actually you'll see a lot of puzzles actually use killer cages without even bothering giving you a total at all, just to give you purely the geometric side of it. And so I think that actually turns out to be a huge part of why killer cages end up being so interesting. But anyway, I wanted to at least sort of emphasize these two different pieces. And you're going to see a lot of that across the puzzles we're going to do today. By the way, a special thank you. I called out for puzzles that would be good examples of sort of intro killer puzzles for people to do, and many of my viewers have set some really exciting puzzles. So I'm going to do a bunch of sort of intro killer puzzles where I'll sort of go through this. And then after we are done that, over on the stream, after I've sort of wrapped up this intro video for those of you on YouTube, but for the rest of the stream, I'll then do some harder killer puzzles. So we'll have plenty of killer action today. All right. The first thing I wanted to do, though, is I wanted to talk about the arithmetic condition. How is it that you handle thinking about what ways there are to make totals in a particular killer cage? And so the way I think is most useful to think about it is to think about it either in terms of the maximum or the minimum that could possibly be inside of a cage. So, for example, this cage, if I were to minimize it, the minimum would be if I put 1, 2, 3, 4 in here. And so that gives you a total of 10. Well, that conveniently is the total. So the only way to make 10 in 4 is as 1, 2, 3, 4. Now, this is, and you'll hear a lot of people call this out as the triangular number for 4. This is the sum of 1 plus 2 plus 3 plus 4. And so you'll learn these numbers if you do many Sudoku puzzles. So they go 3, 6, 10, 15, 21, 28. Those triangular numbers all show up both in terms of killer cage sums, but also in terms of other things as well. Okay. So if you ever see a 3-cell 6 cage, you know it's a 1, 2, 3. If you ever see a 5-cell 15 cage, it's always a 1, 2, 3, 4, 5. Okay. But I wanted to point this out because there's a lot of other contexts in which it is still relevant. Okay. So an 11 cage is a classic example where it is still relevant. So the minimum would be 1, 2, 3, 4. That's 10. So that does not add, these digits do not add to 11. How am I going to make them add to 11? Well, the answer is I need to increase this by 1. And so here is the essence of a lot of killer puzzles. There's only one way I can increase the total from 1, 2, 3, 4 by 1. And so that is, I can't, and here's how to think about that. What if I replace the 1 with something else? Well, if I replace the 1 with something else, that something else is going to be at least 5. And so I'm going to increase the total by at least 4 if I replace the 1. If I replace the 2, I could, again, the minimum I could put is 5. I'm going to increase the total by at least 3. If I replace the 3, I'm going to increase the total by at least 2. So the only digit I can replace is the 4. So I have to take the 4 out. The minimum thing I can replace is 5. And now that gets me to 11. Okay. So the moral of the story here is that if you have a cage which is 1 more than maximum, 1 more than minimum, it's actually also forced. Okay. So both 10 and 11, they're unique. There is only one way to make those totals. Okay. What happens when I go 2 above? And so this is the total that setters really love, is to be 2 above. Because when you're 2 above, there's actually 2 ways to make it work. And so again, think about it as starting from the minimum. The minimum is 1, 2, 3, 4. That's 2 less. I need to increase this by 2. Go back to the same logic. If I replace the 1 with something, it would have to be at least a 5. It's already too big. If I replace the 2 with something, it's already too big. I could replace the 3, though, and I could replace the 3 with a 5. That's one way to make 12. But let's just imagine that we have another 12 cage here to look at. That's not the only thing I could do. Oh, I lied. No, that's fine. Okay. That's not the only thing I could do. I could also not replace the 3, in which case I have to replace the 4. But now if I want to replace the 4 with something in order to get to 12, I have to replace it with a 6. And so these are the only 2 ways to make 12 in 4. Okay. Now, I point this out because some people in chat, when I said I was going to do this, wanted me to talk about it. And I think it's a little interesting, and it helps you sort of identify targets right away. This would work equally well if you had a given digit that ruled one of these things out. So if you have a given 3 that rules itself out of a cage, then when you're minimizing it, you can discount 3. And these sorts of things. Now, I want to point out, and I'm going to use this today sort of freely, if you go in the options on Sudoku Pad, there is a killer cage calculator, and that will make pop up over here, right over the rules, all the options for a killer cage. So if this is a 10 sum killer cage in 4 digits, it'll tell you it has to be 1, 2, 3, 4. The 11, it'll tell you it has to be 1, 3, 5. And the 12, it'll tell you it has to be 1, 3, 6 or 1, 2, 4, 5. Okay. So this is going to make our lives easier in terms of thinking about this. And if you don't relish thinking about minimizing and maximizing things, a lot of times just having this calculator will spare you from doing that. But you're going to see throughout today that sometimes having access to this logic at the back of your brain will be useful. And I should point out, everything I said works equally well backwards. So if you instead want to maximize the cage and then figure out, okay, what's the maximum and then what's the maximum minus 1, that'll be unique 2. What's the maximum minus 2? There'll be 2 options, and so on. All right. So let's start today with this gas puzzle by Philip Newman. Uh, and so all of the killer cages in this puzzle are dominoes. And so to start with, before I start filling in digits, just take a second to think about which of these cages are forced just by virtue of being a domino. So one of them that's forced is the 3. The 3 is forced because 1, 2 is the minimum that I can put in a 2-cell cage, and 1, 2 is 3. 4 is forced for the same reason, except it's 1 more than 3. So the triangular number is 3, if you like. This is 1 more than that, so the only way I can make it work is 1, 3. Now, what about the maximum? The maximum I could put in a 2-cell cage is 8, 9, which would be 17. So this one's actually forced. This one's 8, 9. And then the 16 is also forced because the 16 is 7, 9. Even though I don't know, 16 always seems a little sus to me, but 16 has to be 7, 9. It's 1 less than the maximum. Okay. But now we have some stuff marked in the grid. And so now there's more things that are forced. So let's look at this 6 cage. A 6 cage is 2 more. Sorry, a 6 cage is 3 more than the minimum, but a 6 cage normally has 2 fills. By the way, you might suspect that because 6 is 3 more than the minimum, you might suspect that a 6 cage would have 3 fills, which is a completely reasonable thing to suspect given the pattern I've sort of been telling you. But the reason why it only has 2 is because the quote-unquote third fill that's not counting is 6 being 3 and 3. So 6 actually only has these 2 ways of filling it, which are 1, 5, and 2, 4. But there's a 1 in the 4 cage up here, so this is not 1, 5. Would break that. So this is a 2, 4. By the way, Tristan, people are saying the link does not work. So could you try again? Alrighty. So I bet the same thing is going to happen over here with this 14 cage. So the 14 cage has 2 ways of making it, which are 6, 8, and 5, 9. But there's a 7, 9 down here. And so the 14 cage here is going to have to be 6, 8. Okay. And so note that just by sort of like starting at the maximum and working our way down, we're carefully identifying which of these things we should focus our attention on. Okay. What about the 15 cage? Well, that's either going to be 6, 9, or 7, 8, but there's a 7 in the row. So this is in fact 6, 9. Let's see. The 5 cage, and this one you probably know if you've thought about XV Sudoku much before, although we've not yet done the tutorial on XV. It will be coming up. But the 5 cage is either going to be 2, 3, or 1, 4, but there's a 3 in the row, so this is 1, 4. And so this whole puzzle is really set up just to sort of warm you up exactly to the idea of thinking about cages and what the possibilities are, and then ruling them out. So the 7, one way you could see the 7 here is by thinking, okay, these are the 3 possibilities. There's a 1 and a 2 in the row, so I can cross those out. So this is 3, 4. Oops. But that's not the only way you could do it. The other way you could think about it is to say, what is the minimum that these 2 digits could sum to? And you might at first say 3, but actually you could be smarter about that, and you could say, what is the minimum that these 2 could sum to, given that there's a 1 and a 2 in the row? And given that there's a 1 and a 2 in the row, the minimum these could sum to is 3, 4, and oh, look, that's 7, so this has to be 3, 4. Okay. So you can sort of get the idea of sort of thinking about these things through that lens. Okay. And so I also see that this is going to be forced. The 8 cage is going to be forced. Again, one way to think about it with dominoes in particular that I think is very useful is that in every domino, there's always a big digit and a small digit. I mean, just there has to be a digit that's less than half the sum and a digit that's more than half the sum, because otherwise you're not getting to the sum. And so if you think about it, that means that in a 2-cell 8 cage, there's always a 1, 2, or 3. Except in this one, there's not a 3, and there's not a 1 either, because a 1 would go with a 7, and so in fact the digit here is a 2, and then that goes with a 6. And so I think when you're having to sort of do these in your head, and you're having to think, okay, what is the sum? What are the ways to make 8 and 2? Think about it in terms of, okay, the low digit is either a 1, 2, or a 3. The low digit can't be a 4, because then the high digit would also be a 4. That is the upshot of all of this. Okay. Now's probably... Actually, no, sorry. There's one more I can do here, which is this 13 cage. I can do the reverse of what I did for the 7 cage. What's the maximum that this 13 cage could sum to, given that there's an 8, 9 in the row? It's 6, 7, and that happens to be 13. Okay. I should mention, by the way, I did not actually explain this time. This is the gas puzzle from November 29th. There is a genuinely accessible puzzle posted every day over on the Cracking the Cryptic Discord that are designed to sort of be good introductions, be nice, approachable puzzles for people who are starting out. So that's why I sort of start these tutorial days with that. Okay, so let's fill in a bunch of digits now, because I'm sure a bunch of people have been champing at the bit to point out that there are some digits I could fill in. So for example, this 2, 6 here, that 2, 6 pair means this can't be a 2. So that's a 1 and that's a 2. This 6, 9 pair means that can't be a 6. So that's an 8 and that's a 6. Let's see. I'm sure I have some others floating around. This 1, 4 pair means that's a 2 and that's a 4. Let's look at this 9 cage maybe. It's not 4, 5 or 3, 6. So I guess this is either... I don't quite know, actually. Let's see. Where do we look next? There's probably more gimmies if I look around and resist just picking things at random. Let's see. This is not 2 or 4. Oh, I see. Okay, the 10 cage. The 10 cage is the next place to look naturally. So you'll notice the 10 cage doesn't have a 2 or a 4. And so just if you're trying to use this to keep track of your mental list, it doesn't have a 2 or a 4. It also doesn't have a 1, because there's a 1, 4 pair looking at this cell and a 1 looking at this cell. So the 10 cage is also not 1, 9. So the 10 cage has to be 3, 7, and it has to be 3, 7 in that order. And that 3, 7 in that order is going to give us a 6 and a 7 and a 9 and a 7 going up over on that side. Okay. Now this 11 cage, if I look at it, it does not have a 4 or a 6. That did not actually help. But note, by the way, one of the useful features of this Sudoku Pad app version is that if I go over here and think about this cage now and mark out that it can't be a 4 or a 6 and hope that that tells me something, it will remember that I already marked this information about this one. So it actually is quite helpful in that regard. What about the 12 cage? Well, it's not a 3, 9, and it's not a 5, 7. I see. I was supposed to look at this one immediately, and I just refused. So this is a 4, 8. And there's an 8, 9 pair here looking at this cell. So this is not an 8. It's a 4 and an 8, making that a 9 and an 8. So that is most excellent. So I can now look at the 10 cage. It's not allowed to have an 8 or a 6. Let's see. All of that still looks good. What are the last digits floating around in this cage? Or sorry, in this box. I still need a 2. The 2 is going to have to go there. It has no choice. And I also need a 5 and a 6. I don't think I know the order on that 5, 6 yet. But then that means this digit is a naked single. So this digit is a 4, 5, 6, 7, 8. This digit's an 8. So This 6, by the way, has for a long time looked up at this cell, and I just didn't notice it. These things happen. And now that resolves the 10 cage. In fact, the 10 cage has been resolved for a long time because the 10 cages had 2 9s looking at it, so it's not 1 9, it's 3 7. And so it's 3 7 in that order, resolving the 1 and the 3 and the 4 and the 3. So these digits, if I write them in, I still need a 4 and a 5 and an 8. These aren't the 8, so that's the 8 over there. And so I know there's an 8 up here somewhere. And so we get that. That 4 now looks down there, giving me a 1 and a 4 like that. And so so we have all of this going on. Okay, so this cage can't have an 8 in it anymore, because now there's 2 8s looking at it from the top and the bottom. So this is now a 2 9, and I know the order. Namely, it's 2 and 9. This cage can't have... Oh no, I was expecting by symmetry that this one was going to be resolved, but I think it is not yet resolved. Let me write in the rest of the digits in this column and then go from there. We still need a 1 in the column. I've got a 2, a 3, a 4. We need a 5. We've got a 6 and a 7. We need an 8, and we've got a 9. Okay, this is not an 8. It's doubly not an 8. This isn't an 8 either, so that is the 8. This digit is a write-in. I don't know why I didn't see that right away. This is a 2. So now this cage can't have a 2 in it. If I'd have written this in, it would have worked symmetrically, just like I expected. But I didn't write in the 2, and so when I didn't write in the 2, I didn't know that this 9 cage didn't have a 2 in it. So this 9 cage is a 1 8. I think it's an 8 and a 1 in that order. So now I should just go ahead and start writing these in. 3, 5, 6, 7, 8, 9. So these are 3, 5, 7, except this one's not 3 or 7, so it is a 5. You should not be surprised when the center digit of a puzzle that looks like this and is all symmetrically ends up being a 5. The symmetry will often force a 5 into the center. Maybe someday I'll do a tutorial series on what's called girth symmetrical placement, which is basically, I mean, among other things, it explicitly tells you that if your grid looks symmetrical, it has a 5 in the center, if it's symmetrical in a certain way. So that 7 gives me the 3 and the 7. These two digits are... oh, by the way, that's a 6 and a 2 as I look at what these two digits are. They are a 1 and a 9. So these two digits are a something and a something. 2, 3, a 4, and a 6, it sounds like. That 6 looks over and gives me the 4 and the 6. That 4 looks up, it gives me the 5 and the 4. That 6 looks down and gives me the 5 and the 6. So that was an exciting string of events. So now let's just fill in these things. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. These aren't 8. These aren't 6. These aren't 9. This one's not 8 either. So that's a 5, 6 pair, making that a 9 and an 8. I cannot resolve the 5, 6 pair yet, but I can look down the column and see I've got 1, 2, 3, 4, 5, 6, 7 going down the column. This is a naked 5 because there's a 6, 7 in the row. So that makes that a 6 and that a 7 and that a 5. These digits are 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 6, and 9. This is not a 6 or a 9, though, so it's a 3. So these aren't 3. I don't know what I did, but they're not 3 is the thing I'm supposed to have did. The 6 there makes that a 9 and a 6. These digits down here, I need a 1 and a 2, it looks like, so it has to go in that order. These 1, 2, 3, 4, and 5 are the digits that are missing in this row. not resolved yet. These digits, 3, 4, 5, and 7 is what I need here. That has to go in that order, except with big digits, not little digits. That resolves that that's a 1 and that's a 5. While we are at it, that 5 also resolves that that's 4 and that's a 5. So these two digits are a 3 and a 4. Have to go in that order. These two digits are a 1 and a something. 1 and a 3. So they have to go in that order, which resolves that. Which I need a 2 over here. It has to go there. 3, 4, 5, 6, 7, 8, 9 over there. 2, 3, 4, 5, 6, 7 there. And last digit is a 5, which goes there. Very nice. Perfect little intro to how all of these things play together. And it looks like the center is indeed a magic square. Very, very good observation. The rows, columns, and diagonals all sum to 15. Alrighty, so that is sort of a good introduction to how this works with 2-cell cages. Now notice 2-cell cages conveniently dodge the geometry, because you can't have a 2-cell cage that doesn't have 2 cells that see each other. So we're going to do more examples where we have fancier things going on. So this next up one is by Josh Johnson. I should mention that conveniently, thanks to all of my supporters, this is the most voted on puzzle for us to do today. So every day, as part of people supporting the channel, the people who support us on Patreon or YouTube get to vote on what puzzle I will do. This is the most voted on puzzle today, so I will get to do it. If you would like, by the way, to support the stream, you can do so at patreon.com/zetamath, or you can click the join button down below. Thank you to everyone who does, and to everyone who voted for this puzzle. Okay, so let's first look for unique totals. Okay, so thankfully everything here is... So when Killer started, you always got this kind of thing where you got all the cells were covered. So looking for unique totals, I see that 16 has to be 7, 9. Now, that might be the only one that's unique unto itself, but the thing I want to focus on is this double 6 pair. And so the double 6 pair here is interesting because 6... Oh, good point. There's a 7, 9 over here. The reason why the double 6 pair is interesting is because 6 can be done in 2 ways, as we saw in the previous puzzle, but that means that these 2 6s have to be those 2 ways. So one of these is 1, 5, and one of them is 2, 4. But the point is that means that together, these cells are a 1, 2, 4, 5 quadruple, which means I'm not allowed to use 1, 2, 4, or 5 anywhere in the rest of the box. In particular, I can't use 2, 4, or 5. Oops, for some reason this interface is now not working. I can't use 2, 4, or 5 in my 11 cage. So that means this 11 cage has to be a 3, 8. And so that is sweet. And so now already I only have 3 digits left in the box. And so the 3 digits left in the box are, let's see, if you use 1, 2, 3, 4, 5, we need a 6, a 7, and a 9. Okay. I'm just spotting here, the 9 doesn't go in the 8 cage. Because I would need to add a -1 to 9 in order to make that work out. So we're not going to do that. So this needs to be a 1 or a 2 in order to make 8. This over here, because this is 6, 7, or 9, the thing that matches it up in the 15 cage is either 9, 8, or 6. I'm just figuring out what digit do I add to each of these digits to make 15. So we've got all of those. Now, one thing that you might notice if you pay particularly close attention is that there's a 7, 9 pair in row 6 looking at a cell we've marked 6, 7, 9. So actually this has become a naked single 6. which is going to resolve the rest of it. So that 6 makes that a 7, makes that a 1, makes that a 9, makes that a 6 in order to make my 8 15 cages add up. So that 1 now looks down and rules 1 out of here. But here you have to be careful when you look at this cage to notice I ruled 1 out of it. That also rules 5 out of it, because the only way there was a 1 in the 6 cage is if there was also a 5 in it. And now that there's not a 1, there's not a 5, and so now this is a 2-4 pair, so this is now a 1-5 pair. Okay, so we have good mojo going on so far. So let us continue. So now these 3 need to add up to 15. That's not super interesting. Let's see. Where am I looking next? Filling in 1s is often very interesting because it tells you cells can't be 1, which greatly increases the minimum of anything it looks at. So previously, the minimum of these 3 cells was 6, which is not very useful. Because of this is a 1, now the minimum of these cells is 9, which is better, but still not completely done. Let's see. So I see that there is a 6 placed by Sudoku down here. So those 2 6s look into this box. And notice I cannot place a 6 here because of killer cage logic. In fact, actually, Sven's software is smart enough. If you try and put a 6 here, it will actually correctly yell at you. So actually, the 6 goes down here. And if I look closely, the same is true of the 9. Well, not quite the same, but a similar thing is true. The 9 is forced into the 23 cage. And so if you look at our sort of killer calculator, this was a nightmare to begin with. There were 9 possibilities. But now, actually, we know that this cage contains both a 6 and a 9, and so anything that does not contain both a 6 and a 9, we can just immediately rule out. And so we will find that there are only 2 possibilities for what this cage could be, actually. It is either a 1-7 with a 6 and a 9, or a 3-5 with a 6 and a 9. You could have mathed that out without this killer calculator by figuring out that the other digits had to sum to 8. It's not as useful as I was hoping it would be, I'm going to be completely honest, but we'll do our best. Okay. So let's look at some secret logic here. So here's a technique that is very useful in killer puzzles that have lots and lots of digits filled in, which is that often you can use the fact that you know the sum of a bunch of cells in a couple of different ways to figure out what a digit has to be. So for example, what is the sum of the green cells? Well, quite literally by the rules, it is 15 plus 15 is 30, plus 20 is 50. So the green cells sum to 50. Okay, what if I now make these cells purple? What's the sum of the purple cells? Well, the purple cells, by the rules of Sudoku, are the digits 1 through 9 once each. And that will take you a while in your head the first few times you do it, but eventually you will internalize that the sum of the digits 1 through 9 once each, that is also known as the 9th triangular number, it is 45. And so if purple sums to 45, but green sums to 50, well, then I can figure out the sum of this cell, because, well, what does green minus purple sum to? Green minus purple sums to this, and green minus purple is 5. So this digit's always a 5. You can often do this in a bunch of different ways for puzzles. So for example, we can do it again here. So what do the green digits now sum to? So the green digits now sum to 5, which I am counting just as the single digit 5. Plus 25 is 30. Plus 19 is 49. Whereas the purple digits still sum to 45. And so this digit is a 4 by exactly the same logic. And you can apply this same trick in a couple of different ways. One of those ways would be that you could figure out, for example, the sum of these two digits, because if I now calculate the sum of these digits, then I'll get 17 plus 27, which I admit I don't really want to do, but it's 44, 48. So the sum of green is 48. Did I do that right? Yeah, the sum of green is 48. That is very helpful. Okay, so the sum of green is 48. So what is the sum of these two cells? So the sum of these two cells is 3. So these two cells sum to 3, and now I can use my sort of minimizing logic earlier. 3 is only going to work as 1, 2. Okay, and so we can continue chasing this idea down the rest of the puzzle, because now, what do these cells sum to? Well, now these cells sum to 3, plus 16 is 19, plus 27. 19 plus 27 sounds like 46. 19 plus 27. Yeah, sounds like 46. And so this digit must be a 1. And so we keep getting all of these little things going on. Okay. Now, all the logic you do with killer cages also works on the remainders when you know digits. So, for example, this 19 cage, I didn't even really want to show that, but this 19 cage, as soon as I have a 4 in it, what this is really giving me is a 2-cell 15 cage. But there's only two 2-cell 15 cages, and those are a 6-9 or a 7-8. But I can't use the 6 because there's already a 6 in the row. So this actually has to be 7-8 in order for that to work, which is pretty cool. So we get that 7-8 there for free. Okay. Where shall we look now? Shall we just continue and figure out the sum of these two? Maybe figuring out the sum of these two will be useful. Actually, because I know the 7-9, I think figuring out the sum of these two will be useful. So now let's sum all of these. So that sums to 16, 28. 28 plus 23 is 51 or 61? 28 plus 23 is 51. Okay, so these all sum to 51, which means that these two need to sum to 6. Well, that's not actually all that helpful, if I'm being honest. No, it is helpful. These two sum to 6, so what do these two sum to? These two sum to 6, but they're in a 23 cage. So these two need to sum to 17, and the only way to do 17 is with an 8 and a 9. Okay, so that was actually useful. I am sorry, Josh, for insulting your 6. And these are either 1-5 or 2-4. I don't know which yet. But this 8-9 down here rules 9 out of all of these cells. So 9 is now living the good life up in one of these. And now I have to make 12 without using an 8 or a 9. And so if you just look at 12, you'll see there's only a few possibilities, and one of them uses an 8 and one of them uses a 9. This isn't allowed to use either. So in fact, this is a 5-7 cage, exactly. So we've got that. So this isn't a 5 and that's not a 1, because remember these two add to 6. It does place a 7 in the bottom row of this box, but I don't know that I want to mark that just yet. Let's see. I can mark the contents of the 15 cage, I suppose, if I really want to. I don't think I really want to. Okay, what about my 15 cage without 6, 7, or 9? because I'm noticing that I have to make 15 without 6, 7, or 9, and so I'm already thinking, what's the maximum there if I'm not using 6, 7, or 9? And the maximum would be 8, 5, 4, which is not much more than what I'm going for. So I'm going to go ahead and just tick off all the ones that use 6, 7, or 9. Let's see. Those all use 6, 7, or 9. I guess there are an annoying number of options. But I guess the thing I'm supposed to notice here is that they all use an 8. And that's actually not so difficult to see if you do what I was doing before with the maximizing this cage. If I maximize this cage, given that it doesn't have a 6, 7, or 9, the maximum is 8, 5, 4. Well, what if I didn't use an 8 is a question I very often have to ask myself in Sudoku. If I didn't use an 8, then my maximum would be 3, 4, 5, and 3, 4, 5 is less than 15, which is not going to work. So there's always an 8 in this cage, for whatever that is worth. It makes me kind of contemplate looking at this cage. I don't know. So I think the easiest way to resolve this is to ask where the 7 goes in column 6. So where is the 7 in column 6? There's no 7 in these cells because there's a 7-9 pair in the box. There's no 7 in these cells because there's a 7-8 pair in the box. There's no 7 in this cell because there's a 7-9 pair in the row. And there's no 7 in this cell because there's a 7 in the row. So this cell is actually a hidden 7. This technique, by the way I spotted this, if that seemed completely random to you, is by use of what we in the channel call a Jovi wing, which is to note one of these two cells is a 7 and one of these two cells is a 7. So that's 2 7s I'm placing in columns 4 and 5 to account for these two pairs. But as soon as I account for 2 7s in columns 4 and 5, that's all the 7s in column 4 and 5. And so therefore, the 7 that's in column 6 has to go in one of these cells, and then I scan briefly and I know which one it is. It has to go in that one. Okay. And so now here is one of my huge leaks as a killer Sudoku solving person, which is that this cell I now know what it is, but I was just not going to do it. But it's a 3 in order to make this add to 15. And so that 3 makes that an 8 and a 3. For whatever that is worth. Now I've got some 3s here to Sudoku over here. And so the 3 goes over here by the Sudoku, as we know. Let's see. Okay, what about, I don't know if this is going to do anything, but let's try this. Because remember, we know these two sum to 6. So this is 6, 22, 30. So these sum to 52. Okay, so the green cells sum to 52. And so these two cells need to sum to 7. But if I think about 7, again, what's the low digit in my 7? Well, it's not a 1. And it's not a 2 either, because that would require a 5. So this is always a 3, 4. That is the only way that this works. So this we actually can math our way into figuring out it's 3, 4. And now, actually, we need to ask the question, where does 4 go in box 8? And so one of my favorite facts in all of Sudoku is that you can never put a 4 in an 8 cage. So where does the 4 go? It can't repeat in the 22 cage. It can't go in the 16 cage. So the 4 has to be over here. And since these two sum to 6, the 4 over here has to go with a 2. So in fact, actually, we've sort of backed our way in to figuring out that this 23 cage is a 2, 4. And now we know what the 8 cage is. Because the 8 cage is not a 2, 6, and it's not a 1, 7. So the only other low digits that's left is that this is a 3, 5. And so we get that. So Let's continue with our Sudoku. Sudoku here on 3s is going to push a 3 into my 10 cage. So one of the digits in my 10 cage is a 3. Note, by the way, anytime you can pencil mark that a digit definitely goes in a cage, it is worth doing it, even if it's a little weird. So, for example, we did that earlier. We pencil marked a 9 into 4 cells over here, which was maybe something you don't usually see me do. But I think it is worth it in that specific instance. Okay, we know what these digits are, actually. Let's fill them in. So these digits are a 1, got a 2, 3, 4, 5. We need a 6, got a 7, and we need an 8. These are 1, 6, 8. So that's not the 8. And let's fill in the rest of the column, because that might provide us some insight into the 15 cage. So we need a 2, got a 3, we need a 4, we've got a 5 and a 6 and a 7 and an 8, and we need a 9. Okay, so we've got a 2, 4, 9. Well, this one's not a 9. So it is a 2 or a 4. One of these is a 9. That's huge. Because now the 15 cage has a 9 in it. The other two digits need to add to 6. And again, 6 has either got to be 2, 4 or 1, 9. Don't listen to those words. I don't even know how that came out. 6 has got to be 2, 4 or 1, 5. How about that? That sounds better. And as there's a 5 in the box, it has to be 2, 4. The 9's here, so this is the other 2, 4. And so as a result, this box now is what? This box is a 1. Let's see, we've got the 2, 3, we've got the 4 and 5, and we need a 6. So this is a 1, 3, 6. That's the flavor of 12 cage we have, or sorry, of 10 cage we have here. I can say words. Who says I can't? By the way, I need to move the chat over onto my screen. I somehow failed to do that today. That's why I keep looking over to the other screen, because I just forgot to do that. Okay. So, we are making steady progress. Let's fill in this row now. So this row needs a 2, 3. We've got a 4, 5, 6, 7, 8, and a 9. This one I know is not a 3. These aren't 2. That's okay, that's big too. Because there's already a 1, 2 pair in the 27 cage. So the 27 cage already has a 2. So there's no 2 here, which means the 2 in the row actually goes over here. Which, as the very excitable killer calculator is telling me, means I actually already know what the 24 cage is, because it's telling me that there's a 2 in the cage, but also there's a 6 in the box, so it's not that one. So this is actually forced to be 5, 8, 9. I definitely would not have seen that without the killer calculator to excitedly tell me, but I will take it. So the 5, 8, 9 tells me that this is not the 9 for the column, so this is the 9 for the column. The 14 up here is now 3, 4, 7. Do a quick mental check that 3, 4, 7 really is 14. It is, thankfully. So that 3, 4, 7 looks at that, making that a 2 and a 4, making that a 3. That was a 3 just because there was a 3 in here, looking at this 3 over here. So we've got all of that going on. This 4 looks down here, making that a 2, and that a 4, and that a 2. These two digits, we know what they are. Even without the killer calculator, we know what they are, because this cage adds to 15 and contains both a 2 and an 8. And so the third digit has to be a 5 in order to make this add to 15. And, well, we know where the 5 goes even, because there's a 3, 5 pair here. So that's actually the 5, that's the 8, which now makes that the 7 and that the 8. That 7 looks down and makes that the 9 and that the 7. Let's see. And now if I look at where 7 goes in this box, the 5, 7 pair rules out of this row, that 7 rules it out of that row. It's not 3, 4, and it's not that there, so that's a 7. And so now, again, I know 3 of the 4 digits in this cage. If you ever know all but one of the digits, you know the last digit. So 6, 7, and 9 is 22. So the last digit in this cage is a 1. which means that's the 1 because there's a 1 up here. Now that's the 9 and the 6 in order to make that work out. So that's not a 1. That's not a 6. And these cells are, let's see, we've got a, well, we need a 2, got a 3, 4, need a 5, we got a 6, 7, we need an 8. Okay, so 2, 5, 8, and 6. We should double check that that adds to 21. It does. I am happy to report. So this is not a 2. There's a 4 and a 7 in the column, so this is just a 3. As we sort of update our pencil marks. There's a 7 in this column, so that's a 4 and a 7. There's a 9 in this column, so that's not a 9. There's an 8 in this column, so that's not an 8. There's a 2 in this column, so that's not a 2, or an 8, so it is a 5, making that an 8, making that a 2. This I should be able to figure out now. It's a 9. So this is a 5 or an 8, but there's a 1-5 pair here looking up at it. So that's an 8 and a 5. All right. This 5 looks over here, making that a 1 and a 5. This puzzle has had a very nice flow to it, although I'm not sure my brain would have leapt to that this was a 1-star puzzle, which is what it was listed as, but still a good puzzle. Okay, where do 1 and 2 go in box 1 is a question that I should have asked a long, long time ago. Because 1 and 2 in box 1 can't repeat in the 27 cage. They're not equal to 4. So 1 and 2 actually both go in the 17 cage, which means the other 2 digits in the 17 cage need to add to 14. I also know, by the way, that the 2 doesn't go up here. And so if I'm adding to 14, well, I can't be 5, 9. So I've got to be 6, 8, because I can't be 7, 7. 5, 9, 6, 8, or 7, 7. Right. So this is 1, 2, 6, 8 is the upshot of all of that. Oops. And I threw in an extra digit just for good measure. But if you look over here, if you wanted to see this, you'd see 1, 2, 5, 9 and 1, 2, 6, 8 are the only 2 ways to include both a 1 and a 2. And so we can clear out the pencil marks here, and I bet it will be profitable. These aren't 8. These aren't 1, or in the corner. So this is a 1, 2, 6 triple in this row, which tells me I should know what this digit is. Namely, this digit is a 1, 2, 3, 4, 5, 6. This digit's a 7, making that a 9 and a 7. This digit is the one that's not 1, 2, 3, 4, 6, 7, or 9, or 8. It is a 5. Let's see. That 9 looks up here, making that a 3 and a 9. I can ask where the 3 goes in box 7, and it has to go there. I see that there's a 1 and an 8 looking at this 1, 6, 8 cell, so that's a 6, an 8, and a 1. This cell I probably can figure out. 1, 2, 3, 4. It looks to me like it's a 4. These 2 cells are a 2 and something. 2 and a 6, it looks like, in that order, making that a 1 and a 2 in that order. That 2 rules 2 out of this cell, placing the 2 up here. 9 over down here makes for an 8 and a 9. That cell's not an 8, so that cell is an 8. We are zeroing in on the conclusion of this puzzle. So these 2 cells come from... Okay, well, actually, let's do this the easier way. Where is 7 in this column? 7 in this column is here, so that's a 7 and that's a 5. These are now both write-ins, so let's write them in. 1, 2, 3, 4, 5, 6, 7. This is an 8. 1, 2, 3. This is a 4. These 2 cells, 1, 2, 3, 4, are a 5, which goes here, and a 6, which goes there. These two cells are a 1 and 2, 3, 4, 5, 6, 7, 8. A 1 and a 9, which have to go in that order. That gives me the 6 and the 1 and the 6 and the 1 over there. These two cells, 3, 4, and 6, it looks like to me, in that order. And now this bottom part has to be resolved somehow. But by this 5, looking over for the 3 and the 5, and the 4 and the 3, and the 2 and the 4. Really nice puzzle there, Josh. I enjoyed that one a lot. I now worry about the 5-star killers that we're going to be doing later today. If this was really a 1-star killer, I worry somewhat. I feel like I would have given this 2 stars, but anyway, very nice. Lots of good ability to sort of talk about things. So in particular, I think that the biggest lesson to take away from this one is this trick where you can often find the sum of a bunch of digits and then take away some number of other digits to get the sum. So in fact, if we'd have started, we could have written in this 5 literally from the blank grid if we wanted. Alrighty. So let's do more. Alrighty, let's look at Kuraban's killer puzzle. So Curaban has done a bunch of single constraint puzzles that have all been excellent. So this is single constraint puzzle number 3. This is the killer puzzle. And so this is our first instance of some killer cages with no totals. And so just a reminder, a killer cage with no total could sum to anything. I defy any of you to speculate as to what the total of this cage will be. But the point is, even without a total, I'm not allowed to repeat digits within these cages. So normally these 2 digits could, of course, go anywhere in this box, but they can't go here anymore. All right. Now, in fact, actually, and this is something you'll see not too uncommonly, these are actually 9-cell killer cages. And so as 9-cell killer cages that can't repeat digits, that means that actually they always include all of the digits 1 through 9. So in fact, actually, these could have a total at the top. It would be 45 if they did. Okay, so let's go. Oh, and Jessica has donated Happy Gotcha Day to the kitty cat in the world. Thank you, Thank you, Jessica. Much appreciated. All right. So, where are we going to start with this puzzle? I'm sure we're going to start somewhere, aren't we? I can figure out the sum of these 2 cells. Maybe let's do that. Okay, so those sum to 20, 35. Okay, so these 2 sum to 10. That does not seem useful. I can write in things like I know that this is 1, 2, 4, 5, because it's either 5, 2, 4. This is either 1, 4, or 2, 3. That doesn't seem super useful. Okay, I do see something. Okay, this is much, much, much harder than I was expecting, but we'll do this. Okay, this cage, where does it go in the 9-cell cage? And the answer from the 9 is to where these 2 digits go in the 9-cell cage is here. In one of those cells. So I'm sorry, I'm not going to gray these. These 2 cells go here because they can't go here. And they have to appear, because again, this is 9 cells, so every digit appears in here. So what if this was a 1-4 cage? I claim that's a problem. And the reason why it's a problem is because then 1 and 4 look down at this 6 cage. And that's a very bad thing, because then this 6 cage can be neither 1-4, can be neither 1-5 nor 2-4. So that doesn't actually work. And so the break into this puzzle, I think, is to notice that this can't actually be 1-4. It can only be the other one. It can only be 2-3. Which then means that, in fact, 2 and 3 are vertical here. And 2 and 3 being vertical here means that there's no 2 in the 16 cage. Whew. Going to be a long strain. No 2 in the 6 cage, so the 6 cage has to be 1-5. So we get that at least to start as a beginning. At least we have valid pencil marks now. And so just a brief moment before we sort of continue this. How on earth would you think to start this way? So I obviously observed it. Why is this something I even thought of? The reason is because 5 and 6 cages are each cages with only 2 possibilities. And so in absence of anything else to focus on, the cages with only 2 possibilities are the ones that I sort of chose to focus on. And as I mentioned at the very beginning, setters really like killer totals where there's 2 possibilities. 2 possibilities are usually what setters are going to prefer. Okay. Now, what if we look at the other 6 and 5 cage? They have a very similar geometric disposition. So this 5 cage here, it looks at this gigantic region. And so it places its digits there, and that looks at this 6 cage again. And so again, if this was 1-4, that would be a problem, because that would put a 1 and a 4 looking vertically at a 6 cage and break all the possibilities. So this is not 1-4, it is 2-3. Meaning, again, that there's a 2 and a 3 in the yellow stripe. I'll say more about that in a second. And meaning that this 6 cage can't have a 2 in it. So this 6 cage is actually a 1-5. Okay. But somewhere in these 4 cells is a 2-3. Well, it's not up here because there's a 2-3 pair in this box already. So these are not 2-3. They're not anything, in fact. These are the 2-3. So we actually now have actual, digits would be generous. We have pencil marks over here. And so now I'm noticing our 11 cage is a little bit restricted. It's not completely forced, but it can't have a 2 or a 3. So it's got to be either 4-7 or 5-6. Oh. No, I know what it is. Because where does 1-5 go in this cage? That's the question. Where does 1-5 go in this cage? Well, 1-5 in this cage needs to go in one of these cells. Okay, this is beautiful. But there's a 1-5 pair over here. So the 1-5 actually have to go here. And once the 1-5 have gone there, then I definitely know what this 11 cage is. Now it has to be 4-7 because it can't have a 1-5 because it can't have a 5 in it. So this is in fact 4-7. Okay, that was cool. So let's fill in these 3 digits while we're noting lots of things. So we've got 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4, 5. We need a 6. We've got a 7. We need an 8 and a 9. So this is 6, 8, or 9. While we are looking at it. Okay. The 10 cage doesn't have a 2 or a 3. So the 10 cage, I'm just going to, every time I see something that only has 2 possibilities in this puzzle, I'm going to mark it because that seems to be the theme of the puzzle. So this can't have a 2 or a 3. So it's either 1-9 or 4-6. And if it is 4-6, it doesn't go this way. That's not the 4, so that's not the 6 because of the 4-7 looking up there. I don't see anything interesting. Okay, so what do these two cells sum to? So that's 28, 33. So these two cells add to 13. That doesn't seem super useful, if I'm being completely honest. I guess I could ask myself, where do the 2 and 3 end up in this box? Because 2 and 3, because this I should have marked. I should have marked this immediately. And oh, okay, I get the point. This 15 cage and this 14 cage are going to be doing exactly the same dance. That's the point. So this 15 cage is either a 6-9 or a 7-8. And then this 14 cage is either a 6-8 or a 5-9. And so the point is, if this is 6-8, it notably, same geometry, it goes in one of these cells. Oops. These two cells go here. What if they were 6-8? Well, then these digits would have to be 7-9, which don't add to 15. So this can't be 6-8. It has to be 5-9. So not 6-8. Very cool. Okay, so we now have a 5-9 here, and so there are a 5 and a 9 living over here. And the 9 rules 9 out of this, which also rules 6 out of it, which means that this is a 7-8. Now means... okay. Now means 7 and 8 live vertically in this windmill. And now I have to ask myself where 7 and 8 go in box 9. And at first, it seems like the answer is not very useful. I mean, and arguably it's not still very useful. But I noticed you can't put both a 7 and an 8 in a 14 cage. Because if you put both a 7 and an 8 in a 14 cage, you're going to have an awfully big problem with the fact that those already add to 15, and you're going to need a -1 again. So, in fact, this is always a 7-8. In other words, I need to put 2 7-8s in these 4 cells. I can't put them both in the 14 cage, so I always put 1 there. So that means this 14 cage has a 1 in it, as well as a 7 or an 8. If it was 1 and 7, the other digit would be a 6. If it was 1 and 8, the other digit would be a 5. And that's a problem, because 185 reuses the 5. By the way, I'm don't think I said out loud, I know there's a 1 in this cage. Because of the 1 looking over here, and so 1 had no choice but to be here. So it's not 158. So it is 176. And so that is an 8. And we know what this digit is, too, while we're at it. 2, 3, it's a 4. So we can look out and get rid of the 8 from there. I now know there's a 4 here, because I still need to fit a 4 in this propeller, and that 4 tells me that now it has to be up here, which then tells me what this 10 cage is, because it's no longer a 4-6. This propeller is now a 1-9. Uh-oh, I broke it. No, I didn't, sorry. I did not break it. So if this is a 1-9, then I should now ask myself, where does 9 go in column 3? And the answer to where 9 goes in column 3 is not in a box with a 1-9, not on top of a 1-5, not in a row where 9 is already pencil marked, not on top of a 2-3. So in fact, this cell is a 9. Fascinating. Okay, so the 9, I'm going to just go ahead and... Oh no, sorry, I was about to pencil mark something incorrect. So, can I get away with putting a 9 in this 14 cage? If I put a 9 in the 14 cage, I have to ask myself, what would it go with? So the 1 in the box is already gone. So if I put the 9 in the 14 cage, it needs to go with a 2 and a 3, which unfortunately seems plausible to me. So we're going to abandon ship on that question for a little bit. I think. Okay. I am noticing that these digits are a hidden quad, by which I mean that the 4, the 2, the 3, and the 9 in this box are all forced to go here. So these are 2, 3, 4, and 9. Okay. And so here's a killer trick that I really like, that I don't see a lot of people using, but that I really like, which is all but one of these digits has to go in the 14 cage. Well, the sum of all of these digits is 18. So which digit am I kicking out? Well, the digit I kick out has to make up the difference between 18 and 14. So the digit I'm kicking out has to be a 4. I have no other options for what digit I kick out in order to make this add to 15, as I said it is supposed to. And now that 4 looks over here and gives me a 7 and a 4. The 7 looks back over, rules 7 out of these two cells, places a 7 there. The 1-6 pair looks over here and gives me a 5 and a 1. The 5 looks over here and gives me a 9 and a 5. The 9 looks over here and tells me that's not a 9, and that's not a 9. The 1-6 pair, though, looks over at that and tells me that that's an 8 and a 6. I had missed clearing a pencil mark there a long time ago. The 8 looks up at the 7 and the 8. So we are progressing. These 3 cells, I just want to write in, they are a 6, 7, and an 8 is the answer. I don't think I yet know which of those is going over here. All good things in time, I suppose. When I filled in this 1 and this 5, I did learn that the 1 and the 5 can be pencil marked over here. I don't know if that's worth pencil marking yet. I probably should be looking at something else. Let's see. I've got to somehow break into this 10 cage by using some of this propeller stuff or something, I think. Okay. So there's definitely a 4 in here. I can say that much. One of those cells is a 4. I'm only missing one digit. It's whatever that digit is that goes and joins this bunch of stuff. Okay. I'm just going to gratuitously pencil mark this box because I'm interested in the 14 cage. 2, 3, 4, 5, 6, 7, 8, 9. Okay. So these are, while I'm at it, oh, maybe I can't rule anything out of these. Oh, these aren't 4, I know. Okay, so what's the sum of all 5 of those digits? 2, 3, 4 is 9, and 9 and 6 is 24. So, yeah, so I knew this from before. These two digits need to add to 10. So neither of them can be a 9. That's the point. So by the fact that the whole box sums to 45, these two digits add to 10. So neither of them can be a 9 because the 1 in the box is gone. So the 9 is always up here in the 14 cage, which means that it's joined by a 2 and a 3. So these are not 2, 3. These are not 2, 3. So this has to be 4, 6. I know, however, that the 4 in this propeller is horizontal, so that's not a 4. So that's a 6 and a 4. Okay, that's cool. Okay, so now the 6 in the propeller I know is vertical. It joins the, joins the 7. and the 8. Let's see. Because that means that these 3 digits, right, I know something else. The 6 in this propeller is horizontal, so the 6 is in one of these 2 cells. That's not a 6 anymore. And these digits are, see, I've got the 1, 2, 3. I need a 4, 5, 6, 7, 8. And this is not the 4 because I need a 4 in my propeller. So these 2 cells are now just continuing to Sudoku along. I've got 1, 2, 3, 4. These are a 5 and a 6, and they go in this order. That resolves the 1 and the 5. The 1 resolves the 9 and the 1. That 9 says that's not a 9. All well and good, I believe. All right. I don't quite know about the nature of this whole 6, 7, 8 business yet, but we are slowly progressing here. Maybe not that slowly. We're progressing. Okay. This digit has to go vertically. Let's see, I'm trying to decide if I'm supposed to do any coloring of particular digits or if I'm just supposed to be looking at killer combinations. So what about this digit? It sees a lot of things. So this digit could be a 2 or a 3. It can't be a 4 or a 5 or a 6 or a 7. Oh, but it could be a 9 as well. So I think this can be, I think this actually can be lots of things. Maybe this is where I'm supposed to look? No, not quite. This still has 3 possibilities as well, I think. But this cell. Okay, this cell might be good. So this cell could be 1. It's not 2 or 3. It's not 4 or 5. It's not 6, 7, or 8, and it's not 9. This cell is a naked single. It can only be 1. So let me go over that quickly. So it's not 2, 3. It's not 4 or 5. It's not 6, 7, or 8, and it's not 9. So this is just a 1. Which is maybe going to be useful. It does force 1 to go in these. So these become a 1, 4, 5, 9 quadruple, which forces these 2 cells to become a 2, 3 pair to finish off the row. So this is one of the 2 3s in the column, for what it's worth. Pardon me while I have tea, because tea is good. Okay. What did that do? Surely it did something. I know that there is a 2 or 3 in this column to finish this off, but I don't know which yet. I don't think this 18 needs any particular digits. It's got lots of possibilities. What am I missing now? I'm sure the answer is something. One of these digits is a 5. Aha! One of these digits is a 5. That's the point. What if one of these two was a 5? That's it. That's it. What if one of these two cells is a 5? Then where would 5 go in this row? 5 could not go here. So 5 would get placed in the 10 cage where it would have to join a 5. That's not going to work. So 5 can't go in either of these cells. That's the point. 5 can't go in either of those two cells. So the 5 does go here. And now the 5 has to go vertically in one of these cells. No, sorry, don't listen to me. The 5's already there. So we've got that 5, meaning that's not a 5. Let's see. Where does the 5 go in this column? I guess the 5 could go there. Okay, I do need to fit a 5. Yeah, I need to fit a 5 into the plus. I really thought that was going to do it right away. But seems not to have. So the 5 in this box is in one of these two cells. That's the punchline. If that were a 5, that would be a 4. Which seems okay to me. I don't know if this 2-3 and that 2-3 are the same. I'm looking to see if there's any sort of fancy coloring I'm supposed to do. I am very open to doing fancy coloring, but I don't see it yet. Okay, so these need to sum to 45. These need to sum to, these need to sum to 25 by the column. That doesn't sound great, if I'm being completely honest. Is there some digit I can't put in this 18 cage or have to put in this 18 cage or something? I don't see it yet. This 2 or 3 is either in the 9 cage where it's over here, but that I do not yet see how to make any use of. Let's see. The 5, I think I know is in... No, I don't. I just know the 5's over here, but the 5 could be there. Darn. 11 cage could still be just about anything. I don't think I gain anything by combining these two cages. Okay. Recollect. This 7-8 is one of these two 7-8s. Okay, let's see. I am going to take advice from chat and look at candidates for this cell. So it can't be 1. I think it could be 2. It can't be 3, because then it would need a 6. It can't be 4, because then it would need a 5. I think it can be 5, with this being a 4. I think it could be 6, with this being a 3. Or 7, with this being a 2. There's a 7-8 pair looking at it around the plus. I think it could be 8. Okay, I'm not seeing this. So chat is telling me that this has a 7-8 pair looking at it from the plus, which I do not quite see. If this were 2-3... What if this was 2-3? I think that doesn't work. If this was 2-3, these cells would be 1, 2, 3, 5. Okay, so here's something helpful. If this cell were 2-3, it would make these cells 1, 2, 3, 5, which would make these 4 cells 1, 2, 3, 5, which is not possible. Because then I would need to make 9 out of 2 of those, and no pair of 1, 2, 3, and 5 adds to 9. So that can't be a 2-3. Okay. So one of these really is a 2-3, for whatever that's worth. So this is not a 2-3, for whatever that's worth. Let's see. Okay. Thank you to my wonderful chat for pointing it out. Are these two 7/8s the same? No, they're not. They're actually different. The reason why they're not the same is that if they were the same, where would it go in this plus? It wouldn't. And so these are actually different 7/8s. These are different flavors of 7/8. And so in particular, this sees both flavors of 7/8. This was listed as 2 stars to David. Okay, so now this is down to only 2, 5, 6. So that makes this a 7 or a 4 or a 3. Sadly, that doesn't always put a 2-3 in here. I would like it if this always put a 2-3 in here. That would be very helpful. Oh, chat has another very good point, which is where is 1 in this column? 1 in this column can't be here or here or here, and it can't go in an 11 cage because it would need to go with a 10. So actually, there's a hidden 1 in the column. So that seems likely to be at least a little bit helpful. So now there's a 1 exactly here. Just by Sudoku. So if there were a 1 in this cage, it would need to be 1, 8, 9 exactly, because I'm trying to place 1 here, is what my hope is. Is there a reason this can't be 1, 8, 9 exactly? The 8 would have to go here. That would have to be a 9. I don't see a reason why this can't be a 1, 8, 9 thing yet. If there is a reason, I don't see it. Let's see. Yeah, the yellow 7/8 isn't in the 10 cage. Does the 10 cage have a 2 or a 3 in it? I don't know. Okay, there's a good point. So where is 4 in this L? And the sneaky question, or the sneaky thing is it's not there, or there. So the 4 in this L is actually in one of these cells, which actually tells me that this is not a 4 and a 5. which finally tells me that there is a 2 or a 3 in here. Okay, gorgeous spot. So there's a 2 or a 3 in here. That's a 2 or a 3. That's all the 2s and 3s for the column. So this can't be a 2 or a 3, or it would be a third 2, 3. So that's a 9, and that is not a 2, or sorry, not a 9. Okay, now I look up to the 11 cage. It can no longer have a 2, 3 in it. So it's either a 4, 7 or a 5, 6. I don't immediately see how I know whether it is a 4, 7 or a 5, 6. But I do see that whether it is a 4, 7 or a 5, 6, the point is that this always has a 6 or a 7 in it. This always has a 6 or a 7 in it. And so that's 2 6 7s. So the fancy term for this, by the way, is that this is a 6 7 virtual pair. Just that to say, I know that there are 2 6 7s somewhere in these 4 cells. So the point is this cell can't be a 7. It's an 8. And so that cell's a 7. So these aren't 8. These aren't 7. Okay, and so that's going to start to peel things apart, I think, hopefully. So this isn't a 7 anymore. There's not a 7 here. So this is not 1 9, it's not 3 7. So this is 2 8 or 4 6. Don't see anything wrong with either of those right off the bat. Let's see. Okay, so now let's look at where 5 goes in this column. Because 5 in this column can't go here. So we have lots of hiddens in this puzzle. So this is not 4 7. This is 5 6, because I need to have a 5 here, which needs to go with a 6. So that's not a 5. And that being a 5 6 tells me that this isn't a 6. So it's a 2 and a 7. So that makes this a 3 and that a 2. This digit is now a naked single 4. It is the last of its kind in the column. These aren't 2. So one of these is a 3, because I know there was a 2 or a 3 in here. In this case, it's a 3. And so that's the 2 for the L. Somehow I knew this wasn't the 2 for the L. I don't remember how I knew that, but I think I knew that. So that makes this not 2 8, it's 4 6. Makes neither of these 6. So one of these definitely is 6. That 2 looks over and makes that a 3 while we're doing things. So I do need a 2 to make an appearance in the plus somewhere. But I don't know where yet. That 4 looks over here and makes that an 8 and a 4. Okay, I've got a Jovi wing on 5s, is the point. Or a 4-9 pair is probably the easier way to say it. This 4-9 pair means that this digit's a 5. Whichever way you prefer. So now 5 is just placed in this whole shebang, because 5 can't repeat in the L, so this is a 5. This row needs a 3 now. 3 is not there, so the 3 is there for the row. This row needs an 8, so the 8 is there. So that's not an 8. These aren't 8. The 8 in this box is in one of these 2 cells. I don't think I know which yet. This is not a 7, I see, because it's a 7-corner pencil mark looking next to that. So there is a 7 up here, and a 6, actually, because this isn't a 6 either. That's the point. So actually, these have upgraded to a 6-7 pair, which means this is now a naked single. It is a naked single 2. So that means that these cells are a 3, 7, 9. That's the 7. These are a 3, 9 pair. Don't know the order yet, but that tells me I know what this digit is. 6, 7, 8. It is an 8. These two cells, 1, 2, 3, 4, 5, are a 6, 9 pair. I don't think is resolved yet, but it does tell me what this digit is in the L. It is not 1, 2, 3, 4, 5, 6, 8, or 9. So this is a 7, which is going to do a lot of resolving. So that's a 6 and a 7. That's a 5 and a 6. That 5 makes that a 1 and a 5. So let's see. That 7 looks down, makes that a 6 and a 7. That 6 looks up, makes that a 9 and a 6. That 4 looks up, makes that a 9 and a 4. Now we can do our trick again. So we can say, what are these digits? They are 1, 2, 3, 4, 5, 6, 7, 8, 9. What's the sum of 1, 2, 8, and 9? It is 20. So the digit I exclude needs to be a 2 to make up the difference. So that is a 2. Those are 1, 8, 9. I'm glad I didn't try too hard to prove that that wasn't 1, 8, 9, because it ended up being 1, 8, 9. A 1 looks over, making that a 9 and a 1. This 9 and 2 look over, making that a 3, a 2, and a 9. This 2, let's see, does the cleanup duty down there. That 3 does the cleanup duty down there. That 1 does the 6 and the 1 and the 4 and the 6. The 9 does the 3 and the 9 and the 2 and the 3. We've got 1, 2, 3, 4, 5, 6, 7. This is an 8. 1, 2, 3, and 4. Very nice puzzle. That one was certainly more complicated than the others, but this gives you an idea as to how powerful the geometry part of the rules of a killer Sudoku are. So this puzzle was really, more than anything else, all about the geometry and the not being able to repeat and being able to play all of that. So this puzzle gives you a really good example of some of those sorts of techniques. By the way, everyone in chat is talking about cats and cat-themed Sudoku. Glum Hippo has the canonical cat-themed Sudoku, which is awesome. Alrighty, so let us continue our examples of killer Sudoku. So we have lots of them to do. So here we've got another pile of dominoes. And so here already, I want to highlight a trick that comes up a lot. I guess this is not actually the best place to highlight the trick, but I'm going to highlight it anyway. Which is that when you see two cages, you often can consider them together rather than separately. So instead of considering this as an 8 cage and a 3 cage, you can consider it as a 4-cell 11 cage. And actually, knowing that this is a 4-cell 11 cage tells you immediately that it is 1, 2, 3, 5, because that's the only way to make it. And then you figure out, okay, well, which of those adds to 8? It's 3, 5, and then that's left over for your 3. So often, even though a cage by itself isn't unique, often it will be unique once you sort of combine it with something else. Okay. Oh, was that really marked as 3 stars and I just misplaced? I would have just placed it later in my queue if I'd have known it was marked as 3 stars, Kuraban. It definitely felt like a 3-star puzzle to me. So now here's where we're going to just start pencil marking things. So this 5, I know it's from 1, 2, 3, 4, because it's either 1, 4 or 2, 3. This isn't the 1, 2. So this is the 1, 2. So we've got that at least that we know about. The 17 is always 8, 9. The 3 is always 1, 2. 4 is always 1, 3. Going by our maximums and minimums. 16 is always 7, 9. And so that sorts out a lot of this box. So that's a 2 and a 1. That's an 8 and a 9. So now this is a 14 cage that doesn't have a 9 in it, because there's a 9 there and a 9 there. So this is a 6/8 cage. That's the only way that I can make 14 without a 9, as you can see. And so it is an 8 and a 6 that have to go in that order. This is a 6 cage that doesn't have a 1 in it. So it has to be 2, 4, and it has to go in that order. Okay. Now, speaking of 14 cages, this 14 cage now sees the 6/8 way of making 14. And so actually we could have started here if we wanted. We could have started by pencil marking that these 14 cages had to be exactly a 5, 9, and a 6/8. But we know the order now. This is the 5, 9. Oops. This is the 5, 9. And it's sorted out by this 3, 5 pair, making a 9 and a 5. I know the 4 is a 1, 3, or sorry, I know the 4 is a 1, 3 cage. The 7 is not 2, 5 or 3, 4, so it's 1, 6, going in that order. And that's going to do a lot of sorting, because it's going to sort out that that's a 3 and a 1. It's going to sort out that that's a 2 and a, sorry, not a 2 and a 4, a 2 and a 3. Better. And now we have this 14 cage, which now sees, now has 5 ruled out of both of its cells, because there's a 3, 5 pair here and a 5 pair here. So this can't be the 5 flavor of 14. This has got to be the 6/8 flavor, and I know the order. And so I continue along my merry way to look up here. And so this 14 cage, and so this is a different flavor of this deduction. This is also useful. So I want to look at these cells. Is the 14 cage, well, what is it? It's either a 6/8 or a 5, 9, but it can't be a 6/8 actually for a reason that's a little trickier to see, which is that a 6/8 looks at this cell. And so if this cell can be neither 6 nor 8, this certainly can't be a 6/8 cage. So this is a 5, 9 cage. And it has to go in this order, 5 and 9, like that. That now lets a 9 look over at my 15 cage. And my 15 cage now is now forced to be a 7/8 and not a 6, 9. Okay. Now, I want to actually rewind here just a second before I fill that in and point out that this would have been a much smarter place to apply my "you can add 2 cages together" comment at the beginning. Because a 15 cage and 2 is not unique. A 14 cage and 2 is not unique. But a 29 cage and 4 is unique. Namely, a 29 cage and 4, because that's 1 less than the maximum of 30, is always 5, 7, 8, 9. And then you just ask where the 7 goes. Well, not over there, because that would require a second 7. And so the 7 goes over here, meaning it's joined by an 8. And so you get 5 and 9. And so if you prefer, you could have, as your first move of this puzzle, actually done all of that. And just sorted all of that out. So anyway, that's just a better example than the one I gave before, which is a pretty bad example. The 9 looks down there and makes that a 5 and a 9. Okay. We've got now this 10 cage can't have a 9, can't have a 2. So this is either 3, 7 or 4, 6. And so it's either 3, 7 in this direction, or it is 4, 6 in this direction. I don't know which yet. We have 3 digits over here. 1, 2, 3, 4. We need a 5, 6, 7, 8, 9. These are from 5, 7, 9. Well, that one's not 7. This one's not 9 or 5, so that one is 7, actually. This one's not 7. It is 5 or 9. So let's fill in all of these triples, and if we keep filling in triples, we'll eventually figure out what's going on. We need a 2 for the column, a 3, and a 4, actually. If I did that right. 5, 6, 7, 8, 9. Yep. So these are 2, 3, 4. That one's not 3. This one's neither 2 nor 4, so it is 3. So this one's not 3. These cells are 1, 2, 3, 4, 5, 6, 7. This one's not 7. This one's not 6. Sadly, this one I don't think I know anything about yet. What about this row? 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 7, 9 is the answer. This one's not 7 or 9, so it is a 4. So these are not 4. They are 7 or 9. And that 4 then bounces back and gives me a 2 and a 4 over here. That's going to do it. That 4 gives me a 3 and a 7 over here. So we now have our 10 cage sorted out. These two digits include a 3, which has to go there. Oops. Sorry, include a 3, which has to go there. 5, 6, 7, and an 8, which has to go there. So we've got all of that going on. Now, let's just fill in the rest of our pencil markable stuff, now that everything is pencil markable. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 5, 7 is the answer. That could be anything. This one is a 4, because it's not a 5 or a 7. So this is not a 4. It is a 5 or a 7, and it's not a 7, so it's a 5. Making that a 7, making that not a 7. And now I've got a 5, 6 pair in the row, making that a 7. And so this row, we've got a 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 4, 6. This one's not a 1. This one's not a 1 or a 4, so it's a 6. So that's a 4 and a 6. Uh-oh. Oh, sorry. So that's a 4 and a 1. I just typed the wrong digit. If you type the wrong digit, it does not end well, typically. These are a 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, these are 3, 4, 5. That one's not a 4. This one's not a 3 or a 4, though, so it's a 5. So that's a 3, and that's a 4. Let's see. So, we have made major progress as we have sort of gone around these. So this is a 5 or a 6. This is a triple, actually, of 1, 2, 7, and 8. That one's not a 1. That one's not an 8. This is a triple. 1, 2, 3, 4, 5, 6, 7, 8, 9. A 4, 7, and 9. That one's not a 9. That one's not a 7. Useless, all of you. But this is a 5 or a 9. Which means the 5 is in this row. That's the key point. The 5 in box 3 is in this row, so that can't be a 5. So that's a 6 and a 5 and a 6. I'm going to go ahead and fill in some more stuff. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 8 is what is here. So again, we can use our ones. Again, we can use our sort of Jovi wing technique. So there's a 1 up. Sorry, I did not pencil mark that right. Let's try again. Oh, I pencil marked that wrong too. Okay, sorry. Rewind. Let's try again. Oh, sorry. That is a 5 or a 9, but it sees the 5. So it's a 9, and that's a 5. Sorry, I pencil marked this wrong. This just is a 1, because I need a 1 in this box somewhere. Okay, okay, much better. I I mean, worse technically, but don't be too technical about it. These digits are a 2, 3, 4, 5, 6, 7, 8, 9. That one's not a 6. That one's not a 9. That one could be anything in the world, I believe. Let's see. So where does 4 go in box 8? 4 does not go in any of these cells. So 4 goes in one of these two cells. So that's not a 4. It's a 9, which fortunately, owing to our plethora of chocolate teapot triples, we get to resolve. So that means I'm going to know what's going on, what goes in this cell, because this cell is now, it's not a 1, 2, 3, 4, 5, 6, it's a 7. This is 2, 3, 4, 5, 6, 7, 8. 4, 6, and 8. That one's not a 4. Things are slowly unraveling in the most delightful way, as they say. Okay, so now I'm noticing that 5, 7, 8, and 9 are all ruled out of these digits. So maybe that doesn't quite do what I want. It's possible it does not. Let's see. There we go. Okay. 4 in this box is placed into the cage. So that's the key. 4 in this box is placed into this cage. And so the other two digits in this cage need to add to 10. And so they're not 4, 6. So 6 does not appear in this cage. So does that let me place 6 in this box somehow? It does not seem so. Let's see. 7 is over here somewhere. But 3 is ruled out because of the Jovi wing. Got it. Okay, so the Jovi wing on 3s, which I mean, to be clear, I don't think Jovi ever chastised anyone. She just said it's not an X-wing if it doesn't cross 4 boxes. So that's why it's called the Jovi wing. This Jovi wing on 3s tells me that the 3 in column 6 lives over, in fact, exactly here. That would have been I think, the smarter way to do this. Okay. And so now I ask about 7 in this box. So 7 can't now go in the 14 cage, which needs 2 digits that add to 10. So 7 is placed here. And so that's a 9 and a 7 up there. So now I ask where the 1 goes through the same magical Jovi wing. Through the same magical Jovi wing, or almost the same magical Jovi wing, the 1 in column 6 has to go here. So that's not a 1, which makes that a 1. And now I ask where the 9 goes in this box. And so the 9 now can't go in the 14 cage because it would need to go with a 1. The 9 by Sudoku doesn't go there or there, so the 9 now goes there. So that's not a 9. That 2-6 pair gives me a 9 here. And so so now the only option for this is that we add in 2-6, because we already have a 4. Sorry, 2-8. I need to add in 2-8, because I needed to add in 2 digits that sum to 10 to a 4. So I can't add in a 4-6, or I'd be putting in 2 4s. So this is 4 to 8. And that one's not a 4. That is cool. So now I know what these digits are. In fact, this one I know exactly what it is from the row. 1, 2, 3, 4. This is a 5. I suppose I probably should have just asked where 5 was in this box to start with, huh? That 5 looks up and gives me a 6 and a 5 and a 6. 6 looks down and gives me an 8. These aren't 8 anymore. This digit is known. It is a 2. 2, 3, 4, 5, and 8 go over here, it looks like. This digit is now not 1, 2, 3, 4, 5. It is a 6, making that a 2 and an 8 and a 2 and an 8 and a 6. These are 2 or 4, and that 8 is going to sort everything out through the mechanism of this column. 3 and 5, 1 and 3, 2 and 1. That 6 does the 4 and the 6, and that 4 does the 2 and the 4. Really nice puzzle. I really enjoyed the sort of the way all of these things sort of played together. That was very nice, with a sort of like difficulty spike at the end around resolving this 14 cage. But it was a very cool idea. Alrighty, I think we're going to do 2 more puzzles, and then we'll wrap up the tutorial. But for those of you who are watching the stream, that's not going to change much, but we'll end the YouTube video after I do 2 more. But there are 2 more that were made specifically for this, one by ICHTUES and one by Tyrgannus. So we're going to do this ICHTUES one first. This is a killer with one more restriction, which is that we can't repeat digits on this diagonal. So if you want to think about it this way, really this diagonal is a 9-cell killer cage, basically. There you go. It was a very neat puzzle, Kenny, by the way. I quite enjoyed it. So I think we're going to have to think about 5 and 6 cages again. And so let's initially do the sum trick with these. Oh, that's a 16 cage, not a 6 cage. Let's do the sum trick with these. Together, these sum to 11. And so if these together sum to 11, that means they have to be 1, 2, 3, 5. It's the only way to make 11 in 4. But I can't put a 3 in a 6 cage. So that means I must be putting a 1 and a 5 here, and a 2 and a 3 here. Like that. So that is a start. This 1, 5, 6 cage looks over at the 5. And so, don't listen to me. That is not a sensible thing to say. I mean, it's true, but it is not relevant. So I should look elsewhere. Like, for example, I should write in that the 17 cage is an 8, 9, because that's the only way to make 8, 9 over here. And this is a 7, 9. And so I guess one consequence of writing in these carefully is that I can place 9 in this box. Namely, the 9 in this box goes here. Which tells me this 14 cage doesn't have a 9 in it. So the 14 cage is not 5, 9. It is 6, 8. Which is cool. I am scanning for other such miraculous things. I mean, I know that these are from 1, 2, 3, 4, so that's not a 1, so that's not a 4. Doesn't seem likely to immediately lead to happiness, but maybe it will. Let's see. Then this is either 6, 9 or 5, 8. Where do the 6 and 8 go in box 3? That's a good question. So the 6 and 8 in box 3 by this 6, 8 cage go up here, and I know the order. So these are 6 and 8, and they have to go in that order. Because of this 8-9 cage looking over here. And so these two digits are a 4 and a 7, is the point. So this doesn't have a 6 in it at all, because there's a 6 there and a 6 there looking at it. So this is not 1, 6. So this is either 2, 5 or 3, 4. And if it's 3, 4, it has to be in that order because of the 4, 7 pair looking at it over there. Some are getting lots of hidden triples today. The 8 over, or hidden things, I guess makes sense. Okay. The 8 over in this box lives in one of these two cells. Just by virtue of that. Let's see. So the 6 in this box lives over here. That doesn't seem great, if I'm being completely honest. Let's see. What else should I look at? This 14. This 14 would be a smart thing to look at, because it has a 6, 8 looking at it in the column, so it can't be 6, 8, so it is 5, 9. Which then tells me that this 7 cage is not 2, 5, it is 4, 3, and I know the order. So that is very cool. Let's see. It's going to leave not that many digits for this column. In fact, the 5 in this column is just there, because I need a 5 in this column. I don't have one yet. These two digits are a 1 and a 2 for the column. So these digits are a 6, 7, and an 8 to make that work out. And the 5, 9 resolves the 1 and the 5. Okay, so I'm going to fill in candidates here real quick, because I know that every 14 cage is either 5, 9, or 6, 8, so it always has a 5 or a 6 in it, but this digit can't be the 5 or the 6 because of the diagonal. So this is the 5 or the 6, that's the 8 or the 9. But even better, I have a 14 cage here looking at it that is 5, 9, so this could never be 5, 9. It can only be 8, 6, so we'll go ahead and fill that in, making that a 7. So now this 13 cage doesn't have a 6 in it. I guess that doesn't quite tell me what it is. We'll come back to that, I think. Well, let's fill in these digits first. We need a 1. We've got a 2, 3. We need a 4. We've got a 5, 6, 7, 8, and we need a 9. Okay. Well, I can't put a 1 here because I'd need a 12 here. And as soon as this is 4 or 9, this is also 4 or 9, because 4 and 9 add to 13. So these are a 4, 9 pair. These digits, just for the record, are a 2, 3, 5. No, 2, 3, 7. 2, 3, 7. Just for posterity's sake. Now this 13 cage is fixed. Because if I look at the options, it's not 4, 9, because it's got a 4... Sorry, it's not 4, 9, because it's got a 4, 9 below it. And it's not 6, 7, because it's got a 6 above it. So this is a 5, 8, and I know the order because of that 8. So that's the 8 and the 5, and the 6 and the 8. All good things. And that gives me the 9 and the 8. And now this is forced to be a 6, 7, because it doesn't have an 8 or a 9 in it from the column. So this is a 6, 7. And I know the order because of that 6. So that's a 7 and a 6. To make that work. Okay. This 7 looks at this 15 cage, so the 15 cage is not 7, 8, so it must be 6, 9. And that 6, 9 is then going to sort out this, so that is an 8 and a 5, and a 6 and a 9. This is so much fun. I really enjoy this puzzle. Uh, let's see. So this 12 cage, do I know what it is yet? I don't think I know what it is just yet. 6 in box 1 is placed. 6 in box 1 by Sudoku goes there, which sorts out the 9 and the 6. And I should be thinking about it someday, placing a 9 on the diagonal. The diagonal will be happiest if someday I put a 9 on it. The 6 over in this box is placed. By Sudoku, the 6 can't go any of these places, but there's a 6 on the diagonal, so it can't go there either. So the 6 is actually placed here by Sudoku in this box. And now that's by Sudoku going to place the 6 here, which is going to make that a 7. In order to add to 13. I probably could have done that a different way, but that will suffice. So that is not a 7. 666 going over there. 7, 7. There's a 7 up here somewhere. Got all of that good stuff. Okay. I need a 7 on this. Oh, not quite. Almost. Let's see. Okay. Okay, where is the 9 in this box? I guess the 9 in this box is always in one of these 2 cells. It's not super useful immediately, I suppose. Scan. Row 1 has too many 7s, if I make this a 7, because there's a 7-9 pair here, looking at this. So that's a 4 and a 7. Okay, and now that is going to let me place 7 on the diagonal, once we make that observation. So, by the way, this is not a 4, so that's not a 1. But now where does 7 go on the diagonal? Because there's a 7 in this box. It's not either of those places. It's not there or there, so the 7 on the diagonal goes there. Makes that not a 7. Makes that a 7. Let's see. This row, let's go ahead and fill in. We've got, sorry, we need a 1, 2, 3. We've got 4. We need a 5. We've got 6, 7, 8, 9. So these are from 1, 2, 3, 5. I can't have a 5 again on the diagonal. I've already got a 5 on the diagonal. Interesting. Now I need a 9 on the diagonal, and so now the 9 on the diagonal is placed here. So that is not a 9. This is the last of the 1, 2, 3 for the diagonal. I don't know which one it is, but it's one of them. So 9 is definitely in this column down here. I don't know if that is immediately interesting. Let's see, what else is in here? We've got 1, 2, 3, 4 left to place, is the answer. This one's not a 3 or a 4, though, so this is a 1 or a 2 only. You should maybe try doing this 12 cage, but it still seems a little bit early for that to me. This 7 looks up here and does the 9 and the 7, and that's been there for who knows how long. That's going to do the 12 cage, because now by Sudoku, the 7 goes in the 12 cage, so it has to be joined by a 5, and so it has to be in that order because there's already a 5 there. Okay, so that was very helpful. So this is not a 5, actually. So that's a 1, 2, 3 triple in the box. So we've got our 1, 2, 3, 6, and 7 in the box. We need a 4, 5, 8, and 9. Well, these aren't the 8. That one, at least, is not the 9. Or the 5, just by the column. If this was a 1-4, that would not work. Because if this is a 1-4, that would be 5 cells from 1459. And I cannot have 4 cells from 1459. That's too many. So this is not 1-4, it's 2-3. I'm suspecting there's probably an easier way to figure that out, but that way works, so I'm going with it. So one of these is a 1, so this isn't a 1. In fact, there's a 1, 2, 3 triple in the row, so that's a 5. Let's see. 4 or 8. Let's see. This 5 looks over and says that's not a 5 either. While we're playing the game things that aren't 5. Let's see. Need a 1 on the diagonal, but I don't know where it goes just yet. Let's see. Okay, I've got almost all of my 8s, but not quite all of them. And in this instance, I've got not quite all of them in a way that is very, very unfortunate. They're disposed in that annoying way where they're in 2 of each places that don't align or do anything interesting. Okay. Where is 5 in column 4? That is a question I can answer. 5 in column 4 has to go here because of the 5 up there. I suspect that will do it. Because now if I write in these are just 1, 2, 3, because I've got 4, 5, 6, 7, 8, 9. So those are 1, 2, 3. What about these? Oh, maybe I can't do all of those? This is from 2, 3, 4. I guess I know one of these is a 1. Let me write that in. One of these is a 1 for the row. So these aren't 1. So these are from 2, 3, 4, 5, 6, 7. That one's not a 7. That one's not a 7 either. So actually that is the 7. I could have just placed a 7 by Sudoku if I had Sudoku'd better, as they say. Sudoku harder, not better. I think that's the saying that you're supposed to aspire to as you solve. Let's see. The 4 in this box is definitely in one of these 2 cells. So the fact that one of those is a 4 tells me this isn't a 4. But now, actually, the 1 is also in these. So these aren't 2 or 3. So that became a 2, 3 pair. That became a 1, 4 pair. Making that a 2. And that a 3. That makes that a 2 and a 3. And that, I think, is going to start unraveling everything. So now these aren't 2. That's not 2, but it's not 3 either because there's a 1, 3 pair, so that's a 4. That 1, 3 looks over and makes that a 2 and a 3. 3 looks over here, means that's not a 3, so that's not a 2. I suspect I was supposed to look at this 5 cage a while ago, and it probably would have told me something interesting if I had paid attention to it. I think I neglected this 5 cage, unfortunately. So down the diagonal, I've got the 2 and the 3, so this is a 1. I'm making that a 2 and a 3. This is a 3 for the box, so that's a 2 and a 3. Let's see. Now we've got all manner of things going on. One of these is an 8. I don't honestly know which yet, but I do see that I can place a 3 here by Sudoku. So this cell is a 1, a 2, or a 4, but it's not a 1 or a 2, so it's a 4. So that's a 1 and a 2 and a 1 and a 4. This digit is a 2. These 2 digits are a 1, 2, 3, 4, 5, 6, 7, and an 8. Sorry, a 1 and an 8. If I put them in the right place, it works even better. So now I ask where the 8 is in this box, and the answer is that the 8 is there. So the 8 up here is there. These 2 digits are a 1, which goes here, and a 4, which goes here, and a 5, which goes here. So this is not a 5 or a 9, so it is a 4. So these are a 5-9 pair. Sorry, this is not an 8 or a 4, so it's a 9, and so that's a 5. So this isn't a 4. This isn't a 9. So we are very close to getting this. That 3 looks up, gives me a 1 and a 3. That 4 looks down, gives me the 9 and the 4 and the 1 and the 9. So this is a 2. That's a 1. That's a 4. Excellent point. Excellent puzzle, ICHTUES. I promise this will not be the last ICHTUES puzzle today, as ICHTUES is, I believe, possibly along with Clover, the world-leading killer puzzle setter. So we will be doing another puzzle by them later. This was very fun. I really like domino puzzles, actually. The sort of like the domino killer puzzles. They tend to have a really nice flow to them, and I like that I can do the math in my head. Yeah, the fact that the name is Killer is very unfortunate, as Chad is saying. It is sort of a silly name that involves sort of silly reasons why they thought that was a good name for it. So I should actually say it's a good thing. Why do we call it a killer Sudoku? It is, I believe, because when newspapers started running them, they wanted to say this was the hard Sudoku, and so it was killer as in meant to be difficult, which is a little bit silly, but it is. It is what it is, I suppose. It's probably going to be difficult to rename them cagey thingy Sudokus or whatever, but we can try. All right. And last up for the tutorial, but far from last up for the stream. Let's do the puzzle Crucible by Tyrgannus. Who is another setter who is very famous for killers. And I see right away, looking at this grid, these two incredibly sus 28 cages as well. And so why am I suspicious of the 28 cages immediately? The reason why I'm suspicious of the 28 cages is because there's two kinds of 28 cage. Because 28 is only 2 less than 30, which is the max. And so these have to be one of each, because if these were the same, that would put 6 copies of the same digits. So actually, for free, out of the 28 cages, I get that these digits are all from 4, 5, 6, 7, 8, 9. But in particular, one of these is one of those. One of these is 4, 7, 8, 9, and one of them is 5, 6, 8, 9. But in particular, that also puts a 1, 2, 3 triple in this row, which I'm sure is important. So in particular, all of these digits contain 8 and 9. And so, both flavors of 28 cage contain 8 and 9. The fancy way to think about that is I started with the maximum 6, 7, 8, 9. I got to deduct 2. That means I can't touch the top 2 digits. I can't touch 8 and 9. So how many 8 9s are there supposed to be in all of these cells? There's supposed to be 2 8 9s in all of these cells. Well, I can only put 1 8 and 1 9 in row 4, so these need to be 8 9 to make up the difference. So these cells are an 8 9 pair. Okay. I thought I was going to do exactly the same thing with 2 12 cages here, but I realized that this is actually a 12 cage and a 13 cage. So I'm not quite going to get the same joy out of this. I'm going to note these two sum to 5 because the sum of the rest of this is 40. So these are from 1, 2, 3, 4. Let's see, 25. These three need to sum to 20. That's a lot, actually. These two need to sum to 15. So we're going to look at that. So these have to be from 6, 7, 8, 9 to sum to 15. This is a 5, so it comes from 1, 2, 3, 4. Let's see. People in chat were talking about anti-night, and I was briefly afraid that this puzzle was anti-night, and I had not actually realized that. But it is not. Okay. I'm interested in counting 1, 2, 3, 4s in this cage, but I'm not quite there yet. Oh, the 17 cage is very... I had not sort of fully appreciated that this is a 17 cage. So I think it's worth noting the digits that always appear. And so this is something that you'll notice is that if you have a cage with multiple options, it always has a 1, 2, and a 3 in it. And so we have that, for example, here. And likewise for the 33, we always have a 7, 8, and 9. And you can see that by scanning this little calculator pretty easily. We always have our 7, 8, 9 up here. Unfortunately, yeah, it's not super useful because the 13 cage can't have a 1, 2, or a 3 anyway. And the 7 cage can't have a 7, 8, or a 9 anyway. But we digress. So if this were a 2, 3 cage, this would be a 1. And the effect that would have would be to break this cage. That's the point. Okay. So if I do not put a 4 here, then I make this a 1, 2, 3 triple, and I have to put all of 1, 2, 3 here. That's not going to work. So this has to be 1, 4, meaning this isn't a 1, meaning none of these are 1. Oops. Boy, my keystrokes are not great today. And so the 1 and this 2, 3 must show up over here. So these are, in fact, definitely from 1, 2, 3. And now where is the 4 going in box 9? Well, this 1, 4 looks down here. It's not there. It's not there. The 4 has to go in the 13 cage, making this a 4, 9, meaning that's not a 9. And so that tells me what the 17 cage is, because the 17 cage now can't have a 4. Sorry, can't have a 4. And so now this cage is a 1, 2, 3, 5, 6 cage. So I can fill in these are from 2, 3, 5, 6. The 6 is not over there anymore. Or alternatively, if you prefer, you could remember these added to 15. It turns out that all these different things, ways of saying that the numbers from 1 through 9 add up to 45, end up getting you similar things. Okay, so this is a horrendous mess, but we'll make do. So let's see. I bet I can do a similar thing. I can do a similar thing with a 15 cage, which is that if this 15 cage were 7, 8, oh no, I can't quite. Oh, I can if I am willing to use the row, because the point is what digits can't be. Oh no, maybe not. I was thinking I was going to get a 7, 8, 9 triple here, but I don't. I just know that these are, that 8 and 9 are in these 3 cells. So I don't quite get the same joy out of all of this that I could have. Okay, so never mind. We're going to reconnoiter that one. So there's a 4 in one of this pile of cells. That doesn't seem very useful. I guess I could update that this isn't a 4 or a 9. But that's not my favorite thing ever. So, I mean, I can remember this is not a 7 or an 8, I suppose, if I'm trying to keep things up to date. And so the 12, I know the digits are at most 6. I really don't want this to be 7, 8, but it's not, doesn't quite break. The reason is because if this is 7, 8, then these two are forced to be a 7, 8 pair, but it doesn't quite break. The reason why it broke down here, if this was 2, 3, was it made these 3, 1, 2, 3. But unfortunately, this cell is from 1, 2, 3. It's not an extra 7, 8, 9. And so that is not quite going to work. Let's see, what are the things in my 33 cage? They're either 3 and 6 or 4 and 5. It's fine. I'm not trying to make a swordfish on 1s, am I? I don't think I'm trying to make a swordfish on 1s in a difficulty 3 puzzle. Maybe I should not have so much confidence of that. So let's think about what this 9 cage can be. Because it can't be 1, 8, or 4, 5. So this is always 2, 7, or 3, 6. And that can't be the 7. So because that can't be the 7, this can't be the 2. Is the point that I have to realize that there have to be 2 digits in common between these 2 cages? I mean, I know what one of the digits they have in common is. They both have a 1 in them. So they both have a 1 in them. Tells me there's not a 1 in this 10 cage. Is that at all useful? I don't know. It's gonna get me aligning 1s, which is gonna tell me that there's a 1 over here. Oh, right. No, they don't necessarily both have a 1 and a 2. 13 cage doesn't need a 2, sadly. If a 13 cage needed a 2, life would be better. Let's see. These digits can't be 4. Seems possibly relevant. I don't think there's any way to make these two not have 2 digits that overlap, so I think these 2 digits have to be the digits that overlap between these two, but that seems fancy. Okay, so what are these 3 cells? These 3 cells sum to... Oh, do these 3 cells really sum to 6? Did I miss this whole time? No. 34 is the sum of these, so these sum to 11. That's okay. I fear not very interesting. Okay. And so I know that this 10 cage is not 1, 9, because I know the 2 1s are gone in the rows from here. So this is not 1, 9. So it is 2, 8, 3, 7, or 4, 6. But I don't see any reason why I am invested in those. Aha! Here's the thing I should notice. This cell can't be an 8 or a 9. I mean, I don't know if it's actually going to be useful, but it seems... like the sort of thing I should pay attention to. Oh, okay, gorgeous point from chat. Where does 9 go in this box? Because none of these cells can be 9, or sorry, because these cells need to add to 11, none of them can be 9. You can't put 9 in a 2-cell 9 cage. And because there's a 1 in both of these cages, that consumes the 2 1s for row 6 and 7. Unfortunately, we don't know whether to call this a Jovi wing or an X wing, because we don't know where the 1s are, but we know the 1s aren't here. And so because there's not a 1 here, there's not a 9 here either. And so we've just ruled 9 out of everywhere except here. So this is a 6-9 cage. Very good spot to chat. That was not easy to see. I will immediately mark that gives us this Jovi wing, placing a 9 down here. No 9s up here. So the 9's definitely over here. So the 9 in this box is actually placed. So no 9 in this row, no 9 in this column, no 9 in any of these. That digit just is a 9. Which is cool. I don't actually think I know whether this cage has a 6 or not, as of yet. I may learn that at some point in the future. This is not a 9. This is a 4, 5, or 6. Okay, so this is one of the none 8, 9 digits. Because the fact that this is neither 8 nor 9 tells me that as soon as I know what this digit is, it's telling me what kind of 28 cage this is. Have a great trip, by the way, Dr. Proof. Okay. So we have a virtual 7-8 pair. I don't know if this is worth marking, but we have a virtual 7-8 pair because this in the row, because this is either 2-8 or 3-7, pairs up with that. So no more 7-8s in this row. Let's see. Okay, so the 11 cage, let's think about its possibilities. So it's not 2-9, it's not 4-7. So it is 5-6 or 3-8. Those are the options. Let's write that in. That's not an 8, so that's not a 3. Wait, no. 5, 6, or 4, 7. Yeah, sorry, no. 5, 6, or 3, 8. I'm seeing if this breaks this cage, but I don't think it quite breaks this cage as of yet. All right. So, I know that 2 of 1, 2, 3 are down here. I know that 1 and 1 of 2, 3 is down here at least. Does this have to have a 1, 2, 3 in it? I don't know. We do know one of these is a 1. So this is not 1, 7. This is 2, 6, or 3, 5. It's really weird. So I'm noticing that is aligning with that to give us an almost quadruple. Is weird. Uh, I should use my pencil marked 1 to note that one of these is a 1. That will make my life much easier. So because I have a pencil marked 1 down here and a pencil marked 1 here. So there's a 1 in one of these two cells. And once there's a 1 in one of these two cells, remember these three sum to 11. So the others sum to 10. And so it's not 1, 9, or 4, 6. So it's the other of 2, 3, 7, 8. So these are, in fact, a 1, 2, 3, 7, 8 quintuple, is how this has to work out. I can't put a 4 or a 5 in a 2-cell 10-sum, and so the 4 and the 5 actually go there, meaning that that's not a 5 at the very least. This isn't the 1. 2, 3. So we've got like a virtual 7, 8 pair here. We've got the 9 over down there. Unknown as of so far. Okay, so let's keep reminding ourselves that we know there's a 9 in one of these two cells. I know it's a little messy. One of those is a 9, and the other I don't know as of yet. I don't think. Let's see. Oh, box 3 outies. Let's see. So that's 20, 29, 34. So these two need to sum to 11 without being 2, 9 or 4, 7. So actually we have the same trick up here that we happened before, which is that one of our ways to sum to 11 is 5, 6, and the other is 3, 8, and I have to use both of them, because that's the only things I can use, which makes this a 3, 5, 6, 8 quad, which means that this is not a 3 or a 6, it's a 2 and a 7, which is very cool. So this is not a 7 anymore. Let's see. This is not a 2 anymore. This isn't a 2 anymore. It's not a 7 anymore. Okay. So now this is not any of 7, 8, 9. So I still need all of 7, 8, 9 in this cage, but they all have to go up here now, which seems relevant. To me, there's a 7 over in one of these two cells. Now. Let's see. If the 8 were up here, it would place an 8 exactly there. But I don't see anything immediately wrong with it. These two add to 5, remember, because the rest of these add to 40. So as soon as that can't be 2, that can't be 3. Don't really want to pencil mark all the ways to make 7, I'm going to be honest. One of these is 7, 8. I don't quite see what to do with that. Let's see. One of these two has to be a 5 is interesting. So it means this cell can't be a 5 at least. And if that cell can't be a 5, this cell can't be a 6. And one of these is a 6 as well, for exactly the same reason, so that can't be a 6. And so that can't be a 5, so that makes this a 3-8 pair. Got it. Okay, so that's not an 8, and that's not a 3. Makes this a 5-6 pair. Interesting. Okay. So how many 5s and 6s are in your typical 33 cage? Well, there's no 6s in this one, is the point. So 6 no longer goes in the 33 cage. So the point is we know what the 33 cage is. It's not that one. It is 4, 5, 7, 8, 9. So let's update our pencil marks accordingly. So these are not 9. These are not 5. That one's not 7 or 8 because there's an 8, 9 pair in the row. We do, by the way, we know where the 6 goes in this box now. The 6 in the box now has to go with, or in the 7 cage. So actually, these are a 2 and a 3. That's going to do a lot of damage down here, I think, because that's not going to be a 2, 3 anymore. This is now going to be the 1, because one of these two was a 1. And it's not that one anymore. That being a 7, 8 means this isn't a 7, 8. It's a 2 or a 3. This is not a 6 anymore. Okay, so this no longer has a 7 in it. Still be 3, 6. It can't be 1, 8. So this is either 3, 6 or 4, 5. I don't think I know yet. What about this row? This row's got to be interesting, right? Maybe not. This is a 1, 4, 5, or 6. Vel. I tried. Okay. Do we have a quintuple over here? 2, 3, 5, 6, 8. Right, this is 2, 3, 5, 6, 8. So these are not 2, 3, 5, 6, 8. They must be 7 and 9, because they're the only places, also known as a hidden 7, 9 pair in this column. Don't know if it does anything, but it seems exciting. And then where does the 8 go in this quintuple? The 8 in the quintuple goes here, making that a 3, making that an 8, removing 8 out of all of these. And now this has to be the 5. So these are not 7 or 9. So that gives us a 4, 7, 9 triple up here. So now, hopefully, this is going to tell us what that 9 cage is. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So now this is can only be a 4-5 cage. And so now these are a 6 and a 7, and we know the order. That 6 looks over and tells me the order of the 1 and the 6 over there. The 1 looks over and tells me the order of the 1 and the 4 over there. I think in my mind that was going to do more than it did. And we got to put a lot of pencil marks in the grid, but not strictly speaking profitably. I've got a 7-8 pair in this row. So 8 and 9 are not here. But I can put an 8 and a 13. Oh, wait, no, I can't put an 8. Okay, good point. Okay. So where do 8 and 9 go in this row? I can't put either of them here. And actually, even though I can put I can omit a 2 from a 13 cage, I still can't put an 8 in a 13 cage. So the 8 in this row actually only has one place to go, which is here, and then the 9 goes there. Because the 9 even more can't go in these places. So we have that. Don't know that it does even a little bit, but it gets us more digits in the grid. This 3 I see looks down and tells me that's not a 3 for whatever that's worth. Let's see. Yeah, unfortunately, this can be a 7, because if this couldn't be a 7, the 7 would have to go in the 13 cage, and that would be great. But sadly, we still can put a 7. We can't put a 7 in the 13 cage, because this 13 cage sees 7 in all of its cells. There we go. So, the 7 can't go in the 13 cage anymore. No 7 for you. Because this 7 sees those 2 cells, that 7 sees those cells. That's really cool. Can't put 7 in a 12 cage, so the 7 goes here. Which I think might actually start to do something. So that makes that a 4. Means these aren't 4. This is not a 7 or an 8. It is a 2 or a 3. So this is a 7 or an 8. That gives me a 7-8 pair in the row. Maybe I got all excited for nothing again. This is a 1, 2, 3 for sure. Speaking of things that are 1, 2, 3, these cells are all 1, 2, 3. And so that means this can't be a 2 or a 3. So that's a 6. Over there. That 2, 3 shows up over there. For whatever it's worth. I don't really want to pencil mark that, if I'm being completely honest. So now I know the sum of these cells. So I know the sum of these 2 cells. So this row sums to 45. These 3 cells sum to 24. So these 3 cells sum to exactly 21. And so these 2 cells need to sum to 4, because the total of these is 25. So these are 1 and 3, which is going to do a lot, because it's going to make this a 2 and an 8. And now this is not 2 or 3, so it's a 5. This isn't a 5 anymore. I can get rid of the assorted corner marks here. So that being a 2 and an 8 makes that a 3 and a 7. That 3 makes that a 1 and a 2 and a 3. Makes this 8 a 2, 6. That makes a 9 and a 6, makes a 4 and a 9. That 8 makes that a 7 and an 8. I've got some right-in digits now. So this is a 4, making that a 5 and a 4. This is a 5, doing relatively little. I guess neither of these is an 8. That one's not a 7 either. Okay, maybe at some point these are actually going to resolve themselves. These digits are, for the record, let's get rid of the 9 in the corner. 1, 2, 3, 4, 5, 6, 7, 8, 9 is the answer. This one's not an 8. That one's not a 7. That gives me an 8, 9 pair in this column. Interesting. Not surprising at all, though, I don't think. So, where else can we find Sudoku joy? Probably there is more that I can clean out of pencil marks if I look closely enough. Okay. So this 28 cage needs 8 and 9. It's not getting a 9 there. So where is it getting its 2 8 and 9s? Well, one of them's there. Neither of these can be 8 or 9. This can only be 8, so it has to be getting its 8 and 9 from there. So that makes that an 8. That is not an 8, but now that's an 8. So none of these are 8. So now we know that these are either 5, 6, or 4, 7. Well, there's no 7 in this cage anywhere, so they're not 4, 7. They are 5, 6. So that lets us clear out the 6 and the 5 from these cells. So these need to be 4, 7, 9. That one's not a 7, just by Sudoku. This is one of those times where definitely having the sum calculator is super, super, super helpful. That gives me a 5, 6 pair in this column, so these two are also a pair. They are a 3 and a 4, it would seem. These two are almost a pair. They're a triple. They are from 1, 3, 4, 5, 6. Yeah, they should just be from 1, 5, 6. We should have the 7, 8, 9. Okay. There's a 7 in this box already, so that's not a 7. So this is a 4, 9 pair, so that's a 7. Making that a 9 and a 7. I was briefly excited because I thought I saw a 1, 2, 3 triple, but it was a lie. I did not really see a 1, 2, 3 triple. So one of these has a 6 in it, and that one has a 1, a 3, and a 4. And one of these has a 5 in it, and that one has a 1, a 3, and a 4. Wait. Oh, no, sorry. One of these is not a... they're not both 13 cages. That's the point. They're not both 13 cages. So I don't actually think I know quite what happens. Let's see. So maybe I should figure out if this was a 3, it would make this a 1, 2, 6. I don't know. The 6 looks down here and makes that a 2 and a 6. The 6 looks up and makes that a 5 and a 6. That 6 knocks out those from being 6, which makes that a 6 and a 5. So if this was a 3, I would want 1, 4, and 5. That seems okay. Okay, so I've got lots of 5s. But I don't think I quite know what's going on there. Let's see. Should I go digit by digit? 9s? Am I almost done placing my 9s? No, because I've still got this sort of mess over here. Maybe I should start at the other end and look at 1s, 2s, and 3s. I know one of these two's a 1. One of those is a 1. 2. Oh, that's interesting. 2 in row 3 only goes in one of these two spots. Unfortunately, it does exactly nothing, I think. Let's see. Oh, the 12 gauge always has a 2. Never mind. The 12 gauge always has a 2. And so, the 12 gauge needs a 2, you can see by looking at this. And so, that 2 has to go here. So that's not a 2. Okay. So that 2 looks up, makes this a 1-3 pair, which makes this column have only a naked single left. Which is, let's see, it's not a 1 or a 3, or a 2, or a 4, or a 5. It's a 6. Looks like it's a 6. And now that being a 6 means that there's a 6 in here, and so this is 6, 1, 3 is the answer. So that makes a 1, 2, 3, 6. In fact, actually, this just is the 6, so I don't even have to worry about that, because it's not 1, 3. So that's a 1-3 pair. That makes that a 1-2-3 triple. Makes this 5 and 8. And I know the order. So that is all good. I could start coloring 1-3s if I really want to. Oh, there's a 3 down column 1. That'll help. The 3 in column 1 makes this a 1 and a 2, so this is the 3. So that's the 1, that's a 3, that's a 4. And now those sum to 7, so I need these two to sum to 6, which means they need to be 1 and 5 if one of them is 1 and 5. So this is a 1 or a 5, but it's not a 5, so it's a 1. So that is going to pachinko all around. That is a 3, that's a 2, that's a 3. That 1 and 3 look up and make that a 2. This column needs a 4. Oops, sorry, box doesn't need a 2. I was wrong. 5, 6, 7, 8. It's a 9. 2, 3, 1, 3. 5 looks down, makes that a 4 and a 5. Makes that a 9 and a 4. Makes that a 7 and a 9. Lovely puzzle. So I think that does a pretty good demonstration of sort of the variety of types of logic that you get in killer puzzles. So I really enjoyed this variety. So hopefully if you're watching the tutorial video, you have. So I'm going to wrap up for if you're watching the tutorial video. But for those of you who do watch the tutorial video, I stream on Saturdays and Wednesdays. At least for now, that'll be changing shortly. But please stop by and watch live. I do a bunch of puzzles, and including puzzles that do not make the tutorial videos, which I'll be doing shortly. If you enjoy the tutorial videos, please subscribe and consider dropping by. And if you want to support the channel, people can support us by clicking the join button down below to become a YouTube member, or by subscribing on Patreon at patreon.com/zetamath. Thank you very much, and I hope to see you next tutorial.